When it comes to exploring the solar system, astronomers of the last 400 years have only discovered two major planets that would have been unknown to the ancients: Uranus in 1781 and Neptune in 1846. But that's not for the lack of trying. Hypothetical planets such as Phaeton, a world said to exist between Mars and Jupiter, or Vulcan, a planet closer to the Sun than even Mercury, were once believed to be very real objects. Of course, there are dwarf planets such as Pluto or Eris hiding beyond Neptune, and possibly even an elusive Planet 9 that many astronomers are still hunting today. But with the discovery of the ice giants Uranus and Neptune, as it stands, it seems our solar system is complete. Orbiting the Sun are 8 major planets. Or are there? Because there is a region that we cannot see directly behind the Sun. Could there be an unknown planet on the opposite side of our star? Well, this bizarre idea is one that was actually proposed thousands of years ago. The theory is called counter-Earth, and the planet it describes is named Antichthon. So could there really be a big planet in the same orbit as Earth hiding behind the Sun? How did this theory even come about? And if this hypothetical planet did exist, how would it affect the rest of the solar system? You're watching V101 Space. My name's Rob, and if you enjoy my videos, then remember to subscribe and tap the notification bell to never miss an upload. The idea that there might be another planet in our solar system in an orbit that keeps it permanently behind the Sun dates back at least 2,400 years to the Greek philosopher Philolaus. He proposed the existence of a counter-Earth called Antichthon. Philolaus believed that the cosmos operated according to the principles of harmony and balance. At the centre was a great fire, around which the Earth and other celestial bodies revolved. In his model, however, there must exist another Earth, opposite to ours, to maintain this cosmic balance. He envisioned Antichthon as a celestial body that was hidden from human view, residing on the opposite side of the central fire. This hypothetical counter-Earth played a crucial role in maintaining the symmetry and harmony of the cosmos, serving as a cosmic counterpart to our own planet. Of course, our understanding of the solar system is far greater than that of ancient Greece. But the question nevertheless remains: is there an undiscovered planet directly behind the Sun? After all, from our view, we cannot see this part of space. Although an interesting idea, one that feeds on the imagination of the human mind, if there were an unknown planet directly behind the Sun, we would have seen it by now. For decades we have sent spacecraft out into the solar system, many of which are designed to view the Sun from different angles, and no such world has ever been observed. But what if we simply missed it? Well, even that can be explained away, because a counter-Earth would have a gravitational effect on anything around it, and so researchers would detect its influence on Earth, other planets, and especially our satellites. They would notice if something on the other side of the Sun was gravitationally tugging at planets such as Mercury or Venus, for example. Because of the gravitational effects of each object within the solar system, we can detect large bodies without ever even seeing them. For example, the discovery of Neptune was based on predictions made due to the gravitational effects it had on Uranus. So perhaps a more interesting question is not whether a counter-Earth does exist, but rather whether it could exist. From a purely theoretical standpoint, the answer is yes. Such a planet could exist, hidden from our view on the opposite side of the Sun. But considering everything else that is also orbiting the Sun, it wouldn't be hidden for very long. After all, the solar system isn't just made up of Earth and the Sun. There are many other celestial objects, all moving around in a dynamic cosmic dance. If, for example, the planet Antichthon suddenly appeared somehow in this position behind the Sun, it would only stay there very briefly. The other planets in the solar system would unsettle its orbit with their gravitational influence. This would eventually result in the counter-Earth and the Earth catching up with each other, potentially even creating an encounter. So, a counter-Earth would affect the motions of all nearby objects, allowing us to detect it. But the reverse is also true. Those nearby objects would also affect the counter-Earth. Venus, for example, approaches Earth as close as 40 million kilometers every 584 days. Logically, Venus would also approach the counter-Earth that closely. Venus has about 80% of Earth's mass, so after even a few dozen passes, Venus's gravitational influence would move the hidden world to a position where we could view it directly. And all the while, Mercury, Mars, and even Jupiter would be adding to that influence. However, there are positions within our planet's orbit that are known to be stable, called Lagrange points, one of which is located on the opposite side of the Sun, where this hypothetical planet was said to exist. Lagrange points are places in our solar system where the gravitational pull of any two planetary bodies, as well as the motion of their orbit, combine to create an equilibrium. They are points in space that are gravitationally stable. Objects that we send to these points either tend to stay there naturally or can be kept there with minimal energy because the forces are in balance. NASA has taken advantage of these Lagrange points, most famously with the James Webb Space Telescope, which orbits the Sun at Earth's Lagrange point number 2. Allowing the telescope to stay in line with Earth as it moves around the Sun and retain that orbit using very little fuel. There are even small naturally forming objects orbiting within these points, called Earth's Trojans. Only 2 Earth Trojans have ever been discovered, both located within Lagrange point 4. So what about the Earth-Sun Lagrange point 3 on the opposite side of the Sun? Could a hidden object exist there? While Lagrange points 4 and 5 are known to be stable, Lagrange points 1, 2 and 3 are not. An object located at one of these points would, after some time, drift away, once again due to the gravitational influence of the other planets. You can think of it as being metastable, like a ball sitting on a hill, a little push or bump and it will start to roll away. So we know for sure that there is not an undiscovered planet lurking on the other side of the Sun. And although it is an interesting idea, it is one best kept for the realms of science fiction. Nevertheless, the counter-Earth theory, which was first thought up thousands of years ago, did introduce some interesting ideas. Ones that no doubt influenced later thinkers, helping to lay down the groundwork for discussions about the nature of the universe. I hope you enjoyed this video. If you did, then tap the like button and subscribe. There is plenty more to come. Thank you for watching, and I'll see you next time.